atom surrounding atom in a atom in nucleus around surround the nucleus, electrons move in a certain path or area. What is called this path? This is what is called this path route. This is the nucleus. In an atom around the nucleus there is a circular path where electron move around the nucleus. This is the nucleus, this route, this circular route is called electron is move. What is called this route? In an orbit, in an atom, this circular path, this electron move around the nucleus in a certain path route. This route is called this is called, what is called? This is called orbit. Do you know this? Orbit or energy level or shell or quantum shell. Okay, this is called, so quantum shell. This orbit energy levels all are same. Okay, the energy level, so quantum shell is energy level of an electron. Okay, what is quantum shell?
The energy level of an electron.
The energy level of an electron. Okay, there is a electron. So here we see electron around the nucleus moving some circular path. Actually, where is electron? Electron is not move actually this circular path. Where is the electron probability of finding? This region is not actual, not uniform. Some region is electron finding probability is high. Some region is here electron probability is not. It is scientific scientist trying to find was trying to find out the region area where the electron probability. This the electron cloud. This all region is not equal. Some region is empty. Some region is finding probability is more. So it is not actually circular. Something here is circular, something is here. So probability of finding electrons where is a 90% or above. The reason where probability of electron finding probability is 90% or above, this is called subshell or orbital. This is called what is called? Some region where electron probability is finding like this probability, this area. Here not. Here is some region here electron probability like this. So all electron probability is not same. Some region electron area electron probability is finding more. This region is called orbital. This 19 where the space or region where probability of finding electron is 90% or above is called orbital. Do you know orbital? This orbital means it is the subshell. Orbital means or subshell. This is called subshell. Orbital subshell. Okay, orbital is called. So the size or shape of the orbital means there is a 90% probability of finding electron within their boundaries. So here the orbital. So you know this energy level. How do we find energy level? Energy level. Okay. orbit, electron in an orbit, how we find? This is the first energy level, second energy level. We find this energy level 2n square, number of electron. Okay, this is on the first shell. This is the first shell. This one is shell number 1, shell number 2. Energy level 1, energy level 2, energy level 3, this like so on. Okay, this is the orbital. Like you maybe don't know this thing. Do you know this thing? 1s, 2s, 2p. Do you know this thing? One. This thing is 1s, 2s, 3s, 3p, 3d. Okay, this one is 1. 1 means first energy level. This one, energy level 1. Okay, 2 means energy level 2. Huh? Okay, 3 means like here's the energy level. I give this energy level. It is not actually this way. If I give here 3, this is energy level 3. Okay, this is the energy level 1. This is the energy level 2. This is the energy level 3. Wait. খুব ব্যস্ত না হইলে পরে কল আমি ক্লাস আছে, খুব আর্জেন্ট কিছু নেই, বলেন। হ্যাঁ, আচ্ছা ওকে দিয়ে দেবো নে। আচ্ছা এটা সমস্যা নাই তো, আর বেশি দিন নাই তো, পরে আমরা কলেজে ফেলবে আর সবগুলো ঝামেলা শেষ। আচ্ছা বুঝছি, একটু পরে আমি ফোন দেবো। হ্যাঁ, আমি ক্লাসে আছি। আচ্ছা পরে আমি আপনার ফোন দেবো, আমি বুঝছি আমরা আপনার কথা। ওকে রাখি। হ্যাঁ, hello, this is sorry for saying this is first energy level, this is the second energy level, this is the third energy level. What is these things? This is shell, first shell, second shell, third shell. This is I said this is orbit. Are you listening me? Orbit, energy level, shell, quantum shell, all are same. This is the first energy level, second energy level, third energy level. This is the first shell, second shell, third shell. Are these things? This is the second shell. There is a some subshell. Yeah, this is the subshell here. See, this is the first energy level 1 subshell, only 1s. Second, this 2s 2p. This is the second energy level, second subshell, 2s 2p. 3s 3p 3d. Okay, what is called 3s 3p 3d? It is shell or subshell? Okay, subshell. This 3s 3p 3d, these are subshell or orbital. Okay, 3s orbital, 3p orbital, 3d orbital. Okay. Okay, this orbital, this s orbital, this is the p orbital, this is the d orbital. Okay, this orbital here, if the electron probability okay, this s orbital is spherical, like this is spherical, round. Electron probability is like this here, round probability, spherical. Okay, s orbital shape is spherical. Okay, p orbital shape is dumbbell shape. This is called elongated shape. This way electron probability finding. Okay, dumbbell shape. Okay, this is the dumbbell shape. S orbital, this is the s orbital, sorry, this is the p orbital. Okay, and d orbital shape is double dumbbell, like double dumbbell. D orbital shape like this way. Okay, this okay,
So it is also S.
Huh?
In G10, there is 4s, 4p, 4d, 4s also.
Yes, so on. I am showing this one. Okay, this is 1s orbital. S orbital 1s is smaller size, 2a is bigger size, like 3s alone. The s orbital are spherical, or p orbital are dumbbell. This px, py, pz. Okay, and d orbital, like this is the d orbital. P orbital has 3 dimension: px, py, pz. Means axis, you know, x axis, y axis, z axis. This is along the x axis, px. There is 3 subshell in p orbital. Now Supriyo is now going to join. P orbital, px, py, pz. Okay, now how to draw this p orbital? P orbital, how to join? Draw p orbital. You do this. Px, okay. Here x axis, y, z. What is the shape of p orbital? I have already told. Shape p orbital. What is the shape of p orbital? I am now drawing px orbital. Dumbbell shape. This is the dumbbell shape p orbital. Okay, this is the p orbital. Okay, along the axis. Look, this px orbital is along the x axis. Okay, so what will be py orbital? How that? What will be py orbital? I give this x axis. Do you know x axis, y axis, z axis?
Yes, sir.
Okay. What will be py orbital shape? This will be
Horizontal.
along the y axis. Okay, along y axis. Okay, okay. Now I'll draw the z orbital. I not draw z orbitals. You will see this is, look. Oh, I am showing this thing. This is the z orbital along the z axis. Okay, okay. Now d orbital. D orbital, look, shape, orientation of 3. These are the 5 d orbitals. D orbitals are 5 d orbitals. They like this d orbitals. I down here d orbitals. There are 5 d orbitals. What are these? D xy, dxy, d yz, dzx, d z square, d x square minus y square. dx, sorry, dx comma মা গেছে সবগুলো, dyz, dzx, dz, dz square, yeah, dz square, dx square minus y square. Okay, now I am drawing this dxy. This drawing is given here. I'll not draw these things. Look, x this is dx square y square. This is the along x along y axis. Okay, dx square y square. Dz square along z axis. Okay, dxy dxy loops, this loops x in between the x and y axis, between, not along, between x and y axis. Okay, here xz you draw two axes, it is looper in between, between x and y, not along. Here yz in between y and z. Okay, have you seen this orientation of 3p orbitals? Okay, electrons in an orbit. So all subshell contain 2 electrons. S orbital contain S orbital, all orbital can contain 3 electrons. Each orbital can contain, each orbital contain 2 electrons. So 1s orbital, how many electron can contain? 1s orbital, how many electron can contain? Take, hold. 2 electrons. Okay. Okay, now like 2p orbital, how many electron can contain? 2p has 3 p orbital has 3 part, px, py, pz. So 2p electron can how many electrons? 2p has already 3 part, 3 px, py, pz. So 2p can how many electrons? 6 electron. Yes, good. Because px 2, py 2, pz 2, total 6. Good. And like d orbital, like 3d orbital, how many electron, highest electron can? 8? No, d orbital can 5 sub orbitals, dxy, dyz, dz square, dx square. Each can 2 electron can hold. So total how many electron can hold 3d orbital?
10.
Yes, good. This is 2, 10. Yes, so this is 10. So d orbital high can so s subshell can 8 electrons, p subshell can electrons 6, 3 into 6, d subshell can electrons 5 into 2, then 10. F subshell, there's F subshell, this can 7 electron orbitals, 14 electrons. Okay, now number of electrons in each shell like orbit or energy level. First energy level, how many electron can hold? Energy level can hold electron can hold in an orbit in 2 n square electrons. Each orbit or shell or energy level can hold electrons. This rule, 2n square. So first shell, how many electron? First shell n equal to 1. Put n equal to 1. First shell, how many electron can hold? First shell first orbit. You put n equal to 1 here. For n equal to 1, subshell can electron n equal to 1 put here. 2 into 1 square, that means 2. First shell can hold 2 electrons. Okay, now second shell. Now I'll put here n equal to 2. I will put n 2 into 2 square means 4. 2 into 4, that means 8 electrons. So second shell can hold 8 electrons. So third shell, okay, third shell can, how many electrons? 2 into 3 square. Okay, this is the first quantum shell can 2 into 3 square. 3 square means 9 and 2 8. Okay, 2 into 8 9 8 18. Okay, first quantum shell number of electrons 2. Second quantum shell 8. Third quantum shell 18. Fourth quantum shell 32. Have you understood this thing?
Yes, sir.
Okay. Now this the electronic configuration. Electronic configuration of an atom of an element is the distribution electron among atomic orbitals. Like electronic configuration. Now I see electronic configuration. I will try to make you understand electronic configuration. The electronic configuration of an atom of an element is the distribution of electrons among atomic orbitals. Will distribute electrons among atomic orbitals. Like nitrogen contain how many electrons? Nitrogen atom. Nitrogen contain how many electrons? Okay, this nitrogen contain how many electrons? Sodium atomic number. What is sodium atomic number? Carbon atomic number. What is carbon atomic number? At carbon atomic number 6. Oxygen 8. Nitrogen 7. Oxygen koto, hydrogen koto. How many electrons? Okay, these electrons will distribute. Huh?
I was talking the mic was off.
Okay, someone is near you. Okay, no problem. So here is sodium. Do you know how many electrons in sodium? Sodium is 11 electrons. Okay, 11. So what is electronic configuration? Electronic configuration is the distribution of electrons of an atom of an element among the orbitals. So orbitals, what is orbital electrons? This the we know this, you know this thing, 1s, this the 2s, 2s, 3s, 4s, 5s, 2p, 3p, 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 this 4p. This is the 3d. Okay, electron at first enter to 1s orbital, then 2s orbital, then 2p to 3s, then 3p 4s, then 3d 4s 5s. So electron enter first 1s orbital. So 1s orbital, 1s orbital. Okay, how many electron can contain 1s orbital? highest s orbital 2 1 2 electron. Now then 2s orbital, then two, how many electron? 2 electron. Then 2p 2p
6,
6. Now another orbital need. Total is 1s2 2s2 2 and 2 4 and 6.
11,
Now 3s need how many electrons? How many 1. Good. 2 and 2 4 6 10 and 1 11. Okay, this is the distribution of electrons among the orbitals. This is called electronic configuration. Have you understood what is electronic configuration? Okay, you draw the electronic configuration of phosphorus. Phosphorus is 15. Phosphorus and what is neon? Neon. Okay.
10.
Now draw and submit to my WhatsApp number.
Okay, sir.
My students, she was asking me to video this class, but I miss. Okay, we find the energy on an orbital using L plus L rule. N plus L. So N is orbit, this energy level 3, and D is orbital number L. L is the orbital number. L value for D orbital 3. Okay, so D orbital, what is L value? 0 1 2 2. So now I put this value. Now I find the number D. Total is 5. Energy is 5. Okay. Here, what is energy? 10 minutes remaining. You will join the same link. For 4s orbital, what is N?
4,
4. What is L?
0,
0. Total is 4.
4,
So which is lower energy level? Which orbital is lower energy level? 3D or 4s?
4s.
So 4s lower energy level, 4s at first enter. Okay. For this results, 4s orbital enter. Okay. Now this is the exception. Have you seen this? The calcium and potassium for these regions. Now then again same scandium, titanium, vanadium, chromium. Again there is a exception in electronic configuration of chromium. So what is chromium? What is atomic number? Chromium is 24. This is the 1s2 2s2 2p6, 3s 3p6 18. Then 3d 5 4s 1. Okay. Then manganese
25,
25 to okay. Now I am drawing this chromium electronic configuration. Okay, you say me to chromium. This is the 24. Chromium. Okay, 24. Okay, 1s2 2s2 1s2 2s2 p6 3s2 3p6. Then which one? 3d. Then here will be how many electrons?
1,
4d 4s
4s1.
1. How many electron here? 3d
3d is 5.
5. Okay, this equation I have given here. Complete the electronic configuration for chromium atom. It is spelling wrong. Chromium atom using sp d orbitals. Okay, you will complete the electronic configuration of chromium using sp d orbitals. Okay, here argon up to argon electronic configuration are given. You will complete rest things. Okay, you complete this sp d orbitals. Okay, 18 electron configuration are already given. If you write argon, electronic configuration of argon don't need to write. Next things you write. Okay, complete the electronic configuration of chromium, and now do and submit to my WhatsApp number.
Of chromium.
Hey, yes, chromium. Hello, are you listening me? Hello, students.
Yes, sir.
Okay, this is the chromium. 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s1. You will complete the. You have draw the electron configuration. Not complete. This is already this argon electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6. These things are given already. These things are already have given. You will write already 3d5 and 4s1. These things already given here. Look this electronic configuration. look this question. uh, these things, argon is given like 18 given. These things already given. Argon means these things already given here. Okay, you write only complete 3d5 and 4s1, 3d5 and 4s1. You write here only 3d5 and 4s1. Have you understood?
Yes, sir.
Up to argon electronic configuration have been given. You write complete, write 3d5 and 4s1. Here is a 18 or here is a 6, total 24. Okay, next is okay, now Hund's rule. Hund's state that electron will occupy the orbital singly before pairing take place. Okay, electrons will occupy the orbital single, then before pairing take place. At first single occupy, then pairing. Okay, the electrons will occupy the orbital singly before pairing take place. Now Hund's rule will do complete this rule. Hund's rule, box rules. This Hund's rule, using Hund's rule. This box given here. Hund's rule. I'll write the electronic configuration of nitrogen using Hund's rule. Okay, nitrogen. I'll draw this 1s orbital. This is 1s orbital. 1s orbital, 1s, then 2s orbital. Okay, 2p orbital, how many parts? Sub 2px. Oh yes, you should share these things. Okay, this is p orbital. There is 3 part: px, py, pz. Okay, 3. Okay, 7 electron. At first electron will occupy single spin, then pair, single spin, then pair. This is the 4 electron. Single spin, single spin, single spin. The total is 7 electrons. Okay, this one is correct. If you write this way, hello, are you listening me? No?
Yes, sir.
Okay, Pauli exclusion principle. Pauli exclusion principle is uh, where's my topics? Huh. uh, State that two electrons cannot occupy the same orbital unless they have opposite spins. So, uh, two electrons in an orbital must be opposite spins. Otherwise, they don't occupy. Okay, must be opposite spins. If you do these things, same spin. Sorry, in an orbital, if you do same spins, same spin, they will not occupy. Okay, must be opposite spin, must be opposite spin. This is the plus half minus half. So each orbital electron, two electrons or occupy each orbitals unless will not occupy, cannot occupy unless they have opposite spins. Have you understood? Each orbital must
Yes,
have
sir.
opposite, two electrons must have opposite spins.
Opposite spins.
Same spin will not. This is the Pauli exclusion principle. Okay, thank you for joining today's class. I'll give you
Yes, sir. Thank you,
homework
sir.
homework later. Thank you for joining today's class.
Okay, sir.
Thank you.